All right, let's cut through all the noise, right? Forget the hype, forget all the crazy jargon. If you're here because you really, truly want to understand how blockchain works, like from an engineer's point of view, then you are in the perfect spot. We're going to treat this like a masterclass. We're diving deep into the mechanics, the stuff that gives you that rock-solid foundational understanding.
Okay, so here's our game plan. It's pretty straightforward. First, we're going to compare the different network architectures, the very bedrock of all this. Then we'll open up what I like to call the engineer's toolkit and look at the 10 essential pieces. After that, we're going to follow a single transaction from start to finish to see how it all works together. And we'll wrap up by looking at the 4 main flavors of blockchain that you'll see out there.
So, first things first, network architectures. Look, before you can even dream of building a blockchain, you've got to understand the world it's going to live in. And this choice, this is everything. It literally defines the rules of the game for the entire system.
And this right here is the fundamental question, the first one any architect has to answer. Are we building a system with a single king on the throne? Or maybe a council of collaborators? Or something else entirely, like a swarm where everyone's just doing a piece of the work? Each one has some serious trade-offs, so let's get into it.
Okay, now this table, this is where it gets really interesting, because it lays out the big engineering compromises you have to make. On one end, you've got your centralized network. Think of a single boss. This gives you amazing performance. It's not very complex, but it's also a single point of failure. If that server goes down, the whole thing goes down. Perfect for your classic corporate apps. Then in the middle, you have decentralized networks, and this is where most blockchains live. Here, control and all the data are copied and spread out across tons of participants. What does that get you? Incredible security and resilience, but you definitely take a hit on performance and how fast you can scale. And finally, you've got distributed networks. Now, these also have no central server, but instead of everyone having a full copy, tasks are just split up. This gives you awesome resilience, and it's fantastic for stuff like content delivery networks.
All right, so we've got our foundation poured. Now, let's build on it. We're about to unpack the 10 absolute must-have components you need to build any functioning blockchain. Think of this as your essential toolkit.
Yep, 10. That's the magic number. 10 fundamental building blocks that all have to work together perfectly to create this amazing ecosystem of trust, security, and, well, automation. So let's meet them, one by one.
First up, we have nodes. You've got to think of these as the absolute pillars of the network. Every node is just a computer that's holding a full copy of the blockchain's entire history. So they're not just record keepers, they're also the referees, validating every single thing that happens to keep the whole system honest. Seriously, without nodes, you don't have a network, period.
Okay, next, transactions. If nodes are the pillars, transactions are the lifeblood pumping through the system's veins. And look, a transaction isn't always about money. It can be any transfer of value or information. It's the basic piece of data that the entire blockchain exists to record, securely and forever.
So, all these transactions are flying around. Where do they go? They get bundled into blocks. A block is really just a container, a neat little package of verified transactions. But, and this is the really crucial part, every single block is cryptographically handcuffed to the one that came before it. This is what makes the chain in blockchain. It's a chain of blocks. And once a block is added, it is there for good.
Okay, but wait, how do all these different nodes all over the world run by total strangers? How do they all agree on which blocks are legit? Well, that is the pure genius of consensus mechanisms. This is the official rulebook. It's an algorithm, like the famous proof of work, that basically forces all the nodes to solve a really hard math problem. The first one to solve it gets the prize. They get to add the next block. And the beauty is, everyone else can check their work in a split second. This is how you get a network with no boss to agree on a single version of the truth. It's amazing.
And the glue holding all this security together is cryptographic hashing. The best way to think about this is like a unique digital fingerprint for data. If you change anything, anything, even a single comma, you get a completely different hash. This is what makes the blockchain basically tamper-proof. It is the digital wax seal that makes the whole system trustworthy.
Now, we're not just limited to simple transactions. We have smart contracts. And honestly, these are an absolute game changer. They're basically just agreements, but they're written in code and they automatically execute themselves when certain conditions are met. This completely cuts out the need for a middleman. It's like a superpowered if this, then that statement that runs on a secure, unstoppable network.
So, with all this complex stuff going on behind the scenes, how do you actually interact with it? Well, you do it through a wallet. A wallet is your personal remote control for the blockchain.
It holds your secret keys and lets you sign and send transactions, giving you total control over your digital stuff.
And when you put all these pieces together, what do you get? You get the ledger. This is it, the definitive shared history book for the entire network. It's an unchangeable and, on public chains at least, a totally transparent record of every single transaction that has ever happened. It is the one and only source of truth.
Now, the actual work of adding new, verified blocks to that ledger, that's called mining or validation. This is the work in proof of work. It's all these nodes competing to solve those puzzles we talked about to secure the network. And why would they do that? Well, in return for all their effort and electricity, they get rewarded. This economic incentive is the engine that keeps the whole blockchain running securely.
And last but not least, governance. I mean, think about it. How does a system with no boss, no CEO ever evolve or get updated? That's what governance is for. It defines the rules for how decisions get made, how to upgrade the software, how to change the rules. It's the process that lets the community manage the whole thing democratically over time, and it's absolutely crucial for long-term survival.
Okay, so we've got all 10 pieces of our machine laid out on the table. Now for the fun part. Let's put it all together and watch this thing run. We're going to follow the exact journey of a single transaction, from the second it's created to its final permanent home on the chain.
So, yeah, how does this actually happen? How does a transaction get added? It's not some kind of black magic. It's a very precise 6-step engineering process that makes sure every single transaction is secure and verified before it becomes a permanent part of history.
All right, here's how the journey unfolds. Step 1, you initiate a transaction. Let's say you're sending some crypto to a friend. Step 2, your request gets bundled up with a bunch of others into a brand new potential block. Step 3, this new candidate block is then broadcast out to all the nodes across the entire network. Step 4, now the real work begins. The nodes all run their consensus rules to validate the block and make sure everything is legit. Step 5, once it's validated, bam, the block is cryptographically chained to the end of the existing blockchain. And finally, Step 6, completion. The transaction is done, the record is permanent, and your friend gets their crypto. It's a brilliant process that shows how every single one of those 10 components works together in perfect sync.
Okay, so now that we know how a blockchain actually works, we can talk about how that core design can be adapted. Because, not all blockchains are created equal. That basic blueprint can be tweaked into 4 main models, and each one is built for very different jobs.
So the two you'll hear about most are public and private. A public blockchain, like Bitcoin or Ethereum, is like a public park. It's totally permissionless. Anybody can show up, read everything, and even participate in running the network. A private blockchain, though, is more like a private gated community. It's permissioned, meaning it's controlled by a single company or organization that gets to decide who's allowed in and what they can do.
Then you've got a couple of more specialized types. A consortium chain is kind of like a semi-private club. It's governed by a pre-selected group of organizations, not just one. Think of a bunch of banks getting together or companies in a supply chain like with R3 Corda or IBM Food Trust. And finally, a hybrid blockchain tries to get the best of both worlds. It combines parts of public and private chains to allow for selective privacy and transparency. Ripple's a great example of this, trying to bridge the gap between traditional banking and the crypto world.
So let's just put public and private right next to each other to really nail this down. With a public chain, access is open to everyone, control is completely decentralized, and everything is transparent. But with a private chain, access is restricted, control is centralized with one entity, and data can be kept private. So what's the bottom line? It's always this fundamental trade-off. Do you want open, trustless security for the whole world, or do you need controlled, efficient privacy for your organization?
And that brings us to the final, really big question, doesn't it? We've looked at the network foundations, we've unpacked the 10 core components, we've watched the machine in motion, and we've seen the 4 different flavors. So, which of these models, public, private, consortium, or hybrid, is going to be the one to build the future of finance, of supply chains, or maybe even of governance itself? That engineering choice, that's what's going to define what comes next.